Hello everyone, my name is Banu and I'll be presenting the introduction and the agile planning part of our Toronto Bike Sharing Analytics Tool project. Our project was designed and built a Toronto Bike Sharing Analytics tool using agile development practices. Over two one-week sprints, our team created a Python-based analytics system and an interactive Streamlit dashboard to help users explore ridership patterns. The purpose of the tool is to load and clean real bike share Toronto data, generate meaningful analytics such as trip duration, peak hours, and popular station, apply agile methodologies like backlog creation, sprint planning, TDD, and refractory, and also presenting the insights visually through a dashboard. And our team consists of four members: me, myself, Banu, and other team members of Faizan, Ashwati, and Chinu. And we have also included our instructor Mohammed so that it will be visible for him to capture what we have done and our work throughout our journey. And coming to the project, we created a product backlog in Taiga. This backlog included more than 12 user stories, each written in the agile format. Some examples include loading the dataset, cleaning the data, identifying peak usage hours, showing popular stations, and preparing data for the dashboard. Each user story had acceptance criteria, priorities, story points, and dependencies. We prioritized the backlog from foundational tasks like loading and cleaning to core analytics. And finally, advanced features such as user type breakdown, seasonal trends, and outlier detection. This organized backlog helped the team clearly understand the flow of development and what needed to be delivered in each sprint. For sprint 1, we worked on sprint 1 from November 28 to December 2. Our goal was to build a stable data pipeline and implement the essential analytics functions that would later power the dashboard. The sprint included user stories such as loading the dataset, cleaning the dataset, trip duration summary, peak usage hours, most popular station, along with basic Streamlit dashboard. We tracked our work using the Tiger Sprint board, moving tasks from new to in progress and ready for test, and at the end to the closed state. By end of sprint 1, we had fully functional backend features, a reliable load data function, a centralized clean data pipeline, core analytics like trip duration, peak hours, and popular station summaries, and a backend structure ready for dashboard integration. Now coming to the sprint 2, we worked on sprint 2 from December 3rd to December 7th, and sprint 2 focused on extending the analytics and finalizing the user facing dashboard. The goal for this sprint was to add deeper insights and make the tool interactive. User stories included trip duration categories, ridership breakdown by user type, monthly trends analysis, outlier detection for trip duration, add filters to our already created dashboard, documentation for all the work we have done during the project, and also included planned refractory tasks such as centralizing the cleaning logic and redesigning user story 7 to remove unnecessary external dependencies. By the end of sprint 2, we completed the dashboard, advanced analytics, refractory tasks, and all required documentation. In summary, the introduction, backlog design, and sprint planning stages were essential in guiding the entire project. They ensured that the team stayed organized, followed agile practices, and delivered the analytics tool successfully across two structured sprints. Thank you. And my team member Chinu will be explaining further.
Thank you, Banu. Hello, Professor. Myself, Chinnu. I will be explaining user story 1 to 6. So, moving to user story 1, our goal was to load the dataset reliably from the CSV file, and we implemented the load data function. The function handled two major problems like file not found and unexpected errors. This user story established the foundation for the whole project, as every analytics function depend on the data on being loaded successfully. So moving to the next user story. After loading the data, user story 2 focus on cleaning and standardizing it. The clean data function handles multiple critical cleaning tasks. First, it rename the inconsistent column names, and it also clean fields like start time, end time, and station names. Next, we handles the data column if it exists, and next there is a if we handles the white spaces from all the string columns to avoid issues like duplicate station. The function also converts financial columns into numeric types and removes invalid entries when needed. And moving to the next user story, it is about understanding how long the trips typically last in the data set. Our trip duration summary function converts the trip duration into numeric values and removes the invalid rows. It then returns the meaningful metrics like total number of trips, total duration, average and medium duration, the minimum and the maximum duration. We also added the visualization function like plot trip duration histogram, which uses a Friedman diagnosis rule to automatically set a bin size. This helps user to visually understand the spread of the trip duration while preventing outliers from the overpowering the charts and all. So this user story provides one of the core insights about the system usage. So moving to the next user story, our objective was to find out what time of the day bike sharing system is used the most. We implemented a peak usage hour function, which converts the start time column into data time that will extract the hour and count trips per hour. This gives a complete distribution of usage across the 24 hours of the day. And the accompanying plot function like plot peak usage function shows a bar chart that makes the peak travel time easy to see. Mainly, this information is especially useful for the operational planning, like knowing when bikes need to be redistributed or when the demand is highest. And the next user story focus on determine which station have the highest ridership. The most popular station function takes the clean start station columns and calculates the frequency of each station. This allows us to identify the busiest station in the entire network. The plot function then visualize the 20 most popular station using the horizontal bar chart. And this is a valuable for the city planners who need to understand where the additional station may be required. And coming to the next user story, it is about preparing all analytics result in a structured way for the streamlined dashboard. The prepare dashboard data function is essentially a controller. It first calls the clean data to ensure the data is clean. Then it conditionally computes each analytics like the trip duration, peak hours, and the station counts. Um, only if it necessary, only if the necessary column exists. So all the results are packaged into a single dictionary that the dashboard can use directly. This user story greatly improves the modularity and reduces the duplication, making the project easy to maintain and extend. So that's all from my side, and my team member Faizan will be explaining further user stories. Thank you.
Thank you, Chino. Good morning, Professor. My name is Faizan, and I'll be explaining you the rest of the stories from user story 7 to user story 12. For user story 7, our goal was to understand how long people typically use the bike in a more meaningful way. Originally, this story was designed to calculate trip distance using GPS coordinates and a separate stations.csv file. However, we identified a major issue with that approach. It introduced an unnecessary external dependency, and the coordinates were not reliably available in our main dataset. So, as part of our second major refactoring task, we completely redesigned this story. Instead of distance, we now analyze trip duration behavior by categorizing each trip into like short trip, medium trip, and long trip. Short trips are less than 10 minutes, medium trips are 10 to 30 minutes, and long trips are more than 30 minutes. We implemented a function that converts trip duration from seconds into minutes and then assign each trip into one of these three categories. We also created a summary that counts how many trips fall into each category and visualize it with a bar chart here. This refactoring made the insights more reliable, removed unnecessary data dependencies, and improved the overall quality of our analysis. Uh, for user story 8, we focused on understanding who is using the bike, specifically like members versus casual riders. We created a function that groups the data set by the user type column and calculates two things like the total number of trips per user type, the percentage contribution of each group. To make this insights easier to interpret, we created two charts, one pie chart and one bar chart here. Um, Pie chart shows like percentage sets, and the bar chart shows like actual trip counts. This helps answer important business questions like, are most users daily commuters with membership or occasional casual riders? This story adds a strong business and marketing perspective to our analytics. For user story 9, here, for user story 9, our goal was to identify seasonal pattern in bike usage. When I extracted the year and month from the start time column and grouped all trips by months to calculate the total number of rides per month. We also classified months into seasonals, such as here, winter, spring, summer, and then fall. When plotted this as a line chart to clearly visualize how ridership changes over time, this insights is extremely useful uh, for like predicting future demands, planning bike maintenance schedules, understanding weather-related behavior of using the bike. It also clearly shows how bike usage peaks in warmer months and dips during winter. For user story 10, we focused on data quality control. Real world data often contains errors, for example, trip lasting several hours due to faulty like tracking or some kind of system error. These abnormal values can heavily like distort averages and visualizations. To solve this, we implemented an outlier detection system uh, here with IQR method. What this do is it calculates the lower and upper bound of normal trip durations, then identify abnormal values, flags them using a new column called is abnormal duration, allow us to remove them safely from like further analysis. We also included a visualization to show the trip duration distribution with outliers and without outliers over here. Here. Uh, this user story greatly improves the statistical reliability of all the other analytics in our system. For user story 11, we have to go to another file, which is dashboard.py. This is the file where we created our dashboard. We enhance the Streamlit dashboard with filters so that users can interact with the data instead of just viewing like the statistical charts. These are the filters: data range filters, user type filters, like optional focus stations. You can select which station you are like you want to focus on. These filters allow the dashboard to like instantly update all charts based on the selected data, which makes the tool much more practical for real world analysis and like demonstrations. This step transform our dashboard from a statistical display into an interactive analytics tool. We also like added all the user story charts that were remaining up until now in this user story. For user story 12, we focused on like making our project more professional, reusable and understandable for future developers. For this story, we completed like 4 main tasks. We added doc string to every major functions, explaining like what the functions does, the inputs it takes, what outputs it returns. We created a detailed professional like README file that explains project purpose, setup instructions, how to run the dashboard, explanation of each user story, agile process summaries. We ensured that all the functions were like modular, clearly named, and easy to reuse. After that, we also prepared like evidence for our TDD refactoring, two major refactoring that we done, then agile metrics and collaboration in the screenshots. Uh, To conclude, user story 7 to 12 represents the most advanced phase of our project. In this stage, we focused on improving some things like data quality, business insights, system reliability, dashboard interactivity, code professionalism. These stories transformed our projects from a basic analytical script into a well-structured, testable, refactored, and production-ready analytical tool. For the next steps of like our conclusions and dashboard representation, I would like to call Ashwani. Thank you, Professor.
Thank you, Faizan, for handing over me the session. Now I will walk you through the dashboard we have created during this project. The goal of the dashboard is to help understand ridership patterns, station usage, and trip behaviors using real-time filters. We started with about 904,000 trips. After cleaning the data and applying user-selected filters, the dashboard worked with around 336,000 valid records. The cleaning process actually included removing missing values, fixing date formats, and calculating new fields like trip duration, hour, and month. We calculated the key statistics like average, median, minimum, and maximum trip duration. The average trips last around 17 minutes and the median is about 12 minutes. These numbers help identify normal usage patterns and also highlight unusual trips. We have created the chart which showing the trip duration distribution for the 0 to 99th percentile. We can see that the most bike trips are short, mainly between 5 to 13 minutes. The graph is actually right skewed, meaning long trips do exist, but they are much less common. As duration increases, the number of trips drops quickly. We exclude the top 1% of extremely long trip so we can clearly see the real pattern of typical riders. So the dashboard also shows the peak riding hours. This help understand when the bikes are most used. For example, the morning and evening are the rush hours where the bike riders are using more. This chart explaining the most popular start station, which is our user story 5. We analyzed which stations have the highest number of trip starts. This is useful for bike share operators because it helps with the decision like where to add more dogs or where bike distribution is needed. Mainly, we have categorized the trip duration into short, medium, and long. So we analyzed that they understand what type of trips are most common among riders. So from this graph, we can identify that long trips are very less comparing to the median, where medium is high among the riders. And also we compared the member users and casual users. We have used a pie chart for to using show that. So this help identify customer behavior. For example, the members usually take shorter, more frequent trips, while casual users often take no longer. So the 9.1% is actually having an annual member, where the casual members are dominating around 90% in this. We also looked at the monthly trends to see how ridership changes across the year. This can show patterns related to weather, tourism, or seasonal events. From this graph, we can see that the winter season is the trip count is high in the winter season. Compared to spring, it is very less. We have detected around 22,500 abnormal trips, which is about 6.7% of the filtered trips. After removing these outliers, we have around 313,000 clean trips. This make the analysis more reliable by removing the unrealistic or incorrect interactions. We have the dashboard is actually built using the Streamlit, and it allows users to interact with the data through the filters such as date range, user type, in station selection. These results update instantly and display charts, tables, and summary matrices. So to be conclude, this bike share analytics project gave us a full end-to-end experience from cleaning real ride data to building a working dashboard. Over 2 sprints, we transferred messy rental records into clear, meaningful insights. We applied all Agile throughout the process. Early sprints taught us how to estimate work better and break tasks down. And by the second sprint, our team was much more organized and efficient. The test-driven development helped us to verify key features, and our dashboards highlighted important patterns like seasonal trends, temperature impacts, and usage behavior. So, beyond the technical work, this project actually strengthened our teamwork, documentation, and version control habits. We learned how to plan, adjust quickly, and solve the problem step by step. Overall, this project not only delivered a valuable insight for bike sharing planning, but also gave us a strong foundation for future data analytics and software development work. It showed the importance of clean data, thoughtful testing, and steady progress to build reliable and usable results. Thank you so much for going through the project. Thank you very much.